I just want to welcome everyone. My name is Steph Daly. I'm the Global Competition Coordinator for CSAW. So from wherever you are tuning in around the world, thank you so much for being here. We're really excited to have Jim Routh here for his talk on data science. And before we get going with that, just a couple housekeeping notes. So as attendees, you do have the ability to write in some questions that Jim will address at the end. You can do that at any point. If you have any issues, you can also chat with me and I'll respond to those. And now I will turn it over to Nasser Memon. Nasser founded CSAW 17 years ago. He also worked to establish the NYU Center for Cybersecurity, the Osiris Lab, and more recently the Bridge Program and the Cyber Fellows Program, which he would be happy to talk to you about. He currently serves as the Vice Dean for Academic and Student Affairs. So Nasser is a busy person, a really big figure on NYU Tandon's campus. And so, yeah, Nasser, I'll hand it over to you now.
Yeah, thank you, Steph. Good morning, everyone. It's a pleasure to welcome all of you to CSAW. It's very different this year. I mean, I as Steph said, we've been running CSAW for 17 years now. It started as just a little event that we did to celebrate our 150th anniversary and spread some awareness about cybersecurity. We had just started a cybersecurity lab, and it was very active. Students were very engaged, and thought, why don't we kind of spread this fever, get this enthusiasm out for cybersecurity on campus? And it was just restricted to a campus, right? And after 17 years today, it's grown beyond I ever dreamt about, right? Beyond my imagination. And we, of course, there are many competitions today because cybersecurity has become such an important topic. But we are definitely one of the oldest, one of the largest, and definitely one of the most comprehensive and very student focused. So the thing I'm most proud about CSAW is the fact that it's run by students, right? The students decide what they want to do, how they want to do it, and then it's my job, Steph's job, to really help them uh, sort of get it organized. So all the challenges are designed by them, uh, and, uh, and I think that makes it a very special sort of an event, at least to me. Uh, so of course, this year things have changed. Seesaw has gone virtual. One of the main components of Seesaw that I pushed to maintain for 17 years is that I wanted the finals to be in person because I felt that the networking that that you get by meeting your fellow finalists, interacting with them, networking with them, and then establishing relationships that will take you further down in your career. We always thought was a very, very important thing. And so Seesaw finals, although the prelims take place online, but the finals were always uh, on campus. And over the years, the in-person events expanded to multiple countries. And but because of the time zone difference, it was a bit sort of staggered, right? Interesting thing now that it's virtual, we can actually see what's going on in India, Abu Dhabi, France, and we get a bigger audience, right? So that's a very nice advantage, and we also get folks like Jim willing to come and give a keynote because it's not a matter of coming over to New York City, right? And the time it takes sort of cuts that down. So we are able to bring such distinguished speakers to an audience across the world, right? And people all across the world can look at all the challenges, all the student presentations, etc. So that makes it a very attractive sort of part of the event. What has happened this year, and we'll figure out. We have elements in place to give you networking, meet industry uh, recruiters and stuff of that sort. So give us your feedback. It's the first time we're doing it. If you see any way we can improve it, please let us know. Uh, so I'll stop talking there and introduce our keynote speaker. and Jim Routh. I've known Jim for a long time. I mean, I used to, at least attend a lot of security events and conferences, and you saw Jim all the time, right? He was one of the most prominent CISOs in the country and perhaps in the world, right? And you would see him give talks, and I sort of got to know him, went up and spoke to him. We had one of the largest, and we still have one of the largest, and in my biased opinion, one of the better cybersecurity programs out there. And Jim immediately engaged with us and has been a strong supporter for a long time, right? He is on the advisory council of our Cyber Fellows program, where we give a 75% scholarship to every student admitted. If you don't know about it, you should Google NYU Cyber Fellows. Uh, and and so Jim has helped us shape the program. He's even helping us shape the curriculum, playing a active role in bringing us the sort of improving our curriculum, making it valuable to industry and to working professionals, right? And we're very grateful to him for that. Currently, Jim is the head of enterprise cybersecurity for MassMutual in Boston. He was formerly a security leader in many companies before this. He was at CVS Health and Aetna and JP Morgan Chase, KPMG, DTCC, American Express, and he's had an illustrious career. At Aetna, he developed one of the most mature converged security programs in the private sector. Currently, he also serves on the advisory board of startups and other organizations like the University of California, Berkeley Center for Long-Time Security, the Clear Sky Advisory Board, the CyberStarts Advisory Board, and the Global Cybersecurity Alliance. He was also the chair of the Information Sharing and Analysis Center, the Health one, HISAC, and before that, the FSISAC. He was a board member there. And he also serves on the board of two companies, Excepto and Zero Knot, right? He's received many awards for cybersecurity leadership. As I said, he's definitely one of the most, if not the most prominent CISO today. Uh, and he's in the CSO Hall of Fame. He's received a Lifetime Achievement Award by Shared Assessments, Cynet Impact Award, and others. And as I said, he regularly publishes articles. You see him on the speaker circuit. Most of the large conferences, you might see Jim giving a talk there. And we're very fortunate to have him here today to speak to you. So, Jim?
Nasser, thank you very much. Steph, thank you for the logistics here, for being here. And Nasser, I got to tell you that I would travel. We can do this virtually today, and that's good for the pandemic, but I would always travel for you. And that's because we have a good relationship and have had for a long time, and I value that. So what I'm going to talk to you about is data science being a foundation for cybersecurity, which, as Nasser mentioned, we're actually developing a curriculum around this construct to help both cybersecurity professionals as well as data science professionals dealing with the intersection between data science and cybersecurity. And it may be you haven't necessarily heard people talk about data science as being core to cybersecurity. We passionately believe this at MassMutual. I'm going to share with you really two ways that cybersecurity plays a significant role. One is pretty traditional or conventional, which is data analytics and data quality in cybersecurity. So I'm going to show you some examples of that. And then I'm going to show you something that we call model-driven security, which is literally using data to drive frontline security controls across the enterprise. And we think that's pretty cool, and we're doing quite a bit of work in that. So let's start with the more conventional approach, which is the data analytics and really data quality, data management used for cybersecurity. So in any 24-hour period, there's about 70 people at MassMutual that collate information from inside the enterprise and outside the enterprise on anything that's an anomalistic, anything that's changed, any pattern that's changed across a whole suite of categories of cybersecurity events. And we collect the anomalistic information, and then we bring it forward and come to consensus on the risk implication to the enterprise. So we're looking inside the enterprise, outside the enterprise, all of the changes that occurred. And then there's essentially a consensus building process that we do live every day, where we talk about the impacts of these specific events on the enterprise. And we end up with consensus on an enterprise risk score. And that enterprise risk score reflects the risk profile for the enterprise for that 24-hour period. And then it's updated in the next 24-hour period. We don't do this over the weekend, so it's a 5-day-a-week process. And the beauty of it is there's immediately a clear understanding of not only the enterprise risk, but the impact of specific events and the risk associated with them, that allows us to make decisions on how to allocate scarce resources to the highest risk. And that's always a constant trade-off, but it's really challenging. In a lot of organizations, you might get 5 different security opinions. Like you get 5 different cybersecurity people that look at a common problem or a vulnerability or a platform, and they have different opinions about what the level of risk is. And the problem from a decision maker standpoint, who's got to make trade-off decisions, it'd be much easier if there was just one perspective of what risk is. And that's ultimately what this gets. It allows us to get the IT infrastructure and IT development leads and the cybersecurity professionals, the privacy professionals, really everyone that has a vested interest in the ultimate decisions participates in the process. And because we do it every day, we're good at it. So it sometimes it takes 15 minutes with not a lot going on. Sometimes it takes, an hour, but it's something that is enhanced by quality data. And in fact, the platform was built by our data scientists. And we have a lot of data scientists at MassMutual. And we have somewhere between 6 or 8 of them that are dedicated to the cybersecurity function and program. And they built this platform for us. And it gives us, this is summary information that we send out as a result. So think of a cybersecurity risk score like this as almost a stock market price. If we were a public company, which we're not, but if we were a public company and we saw the stock price go up one day, is that because of something in our environment or something in the market? And you kind of discern that. But the stock price itself is only relevant when you compare it to a previous stock price. Similar, where we can take trend analysis of what the TVA score was for the last 18 months, and we can determine how does today's score compare to yesterday's score or last week's score. And that gives us a baseline to work with. And ultimately, we're just trying to make better decisions. We can also break it down in terms of the risk by category, the types of risks that impact the enterprise in the most significant way. And that's useful information. And then, of course, the external information we get from cybersecurity intelligence sources could be an ISAC or it could be a third party. We always put that in the context of what is the impact to our enterprise and how does that impact the TVA score. So there's a lot of analytics that we use from the TVA process to actually feed a risk prioritization process across the enterprise that helps us make investment decisions. So the risk score for TVA is published every day, but we also, on a quarterly basis, publish the top risks to the enterprise. And the reason we do that is we align the top risks with programs that we're investing in improving our risk management capabilities and our cyber resilience in those specific domains. And of course, those risks will change over time. So this chart kind of shows how software security was a really high risk in 2019. It was number 2. It's dropped down to number 4. It's actually lower to, I think it's number 7 now. And the reason isn't necessarily because threats have changed or threats influenced that, it's actually our software security capabilities and the maturity of those capabilities have improved. And so that's on a relative basis, dropping that down. We're doing less investment because we can, but we're putting more investment to other things like consumer data harvesting. So this is also an example of kind of the richness of data around security incidents. Now, the first thing I have to tell you is when I joined MassMutual, I told the CIO at the time who hired me, I said, look, I'm a bit of a, and by the way, this is my 6th CISO gig, as Nasser mentioned. So I've got, quite a bit of experience, and I know kind of what my philosophy and patterns and methodology is. And I basically said, we're going to triple the number of incidents that that MassMutual has, which it sounds like a kind of a shocking statement, but if you unpack that a little bit, what I'm really saying is that control breaks, these are events that are identified by the cybersecurity professionals where they find weak controls, are going to go up significantly. And the reason for that, and we treat, by the way, a control break the same way we do an incident. So we have 5, and we look at the facts, the business impact, the root cause, the corrective actions, and the lessons learned for every single incident and every single control break as a subset of that. And as you can see from this data, the control breaks in the blue are really high. That's actually a sign of health. That's a sign of resiliency, because it's basically saying that we're discovering vulnerabilities and or control weakness. And that's a lot better than having a threat actor discover that for you and have the business impact associated with that. So actually practicing our incident response process, even on control breaks, is really helpful in improving our level of resilience to mitigate the business impact of incidents. So this is a little bit, another cut at the data. Again, it's thanks to our friends in our data science community at MassMutual. This breaks down, numeric representation of changes quarter by quarter, and the topics or the categories of the incidents that help feed how we look at overall risk across the enterprise. Once again, this is an output from the dashboard that was built by the data science team and gives us really good data to make decisions on. It's all fed into a quarterly process of identifying the top 10 cyber risks for the enterprise. And the reason we do that is we align the top 10 risks with the spend or the programs and projects where we're allocating resources, and we're determining that resource allocation. So I literally give each quarter the top cyber risks to the chairman and the president and his direct reports, and say, look, these are the things that are most important to us, and here's what we're doing in terms of the programs and projects and ways of mitigating that. And then we have KPIs, key performance indicators, for each one of them. All of that is prepared and delivered through data science applied to robust data analytics. And it's kind of foundational to how we make decisions as risks change and evolve across the enterprise. So those are all examples of the conventional use of data science as data analytics. What I'm going to now talk about is what I think is frankly cooler. It's using data science for what we call model-driven security. Now, it's based on a simple construct, and it's important to recognize that this simple construct has thousands of potential use cases. And it basically works like this. You have to accept the premise that any event can be represented mathematically. And if you think about it on a X and Y axis and basically charting the position of every data point, that's one way of representing an event, any kind of event, in a mathematical format. So assuming that we have a streaming architecture that allows us to get access to real-time data, then we can take the established pattern of behavioral attribute and represent that as an algorithm. And then we take the real-time data of the same attribute and we measure that against the pattern to create a deviation score, which is the delta between the real-time event and the pattern that's established for that attribute. And that deviation score is basically a numerical representation of how closely the real-time data matches the pattern or not, or how far it deviates from that pattern. And with that simple construct, we're actually able to identify thresholds that trigger specific treatments where a deviation score, hypothetically above a 10, just to pick a random number, would trigger an orchestration and automated process in real time based on that, how well that event matches the pattern or not. And that simple construct has hundreds, if not thousands, of use cases just in identity access management alone, much less the rest of cybersecurity. So let's give some kind of examples of that model-driven security. So it starts with capturing data. And again, having real-time data is kind of essential to making this work. So architecturally, using something like a NiFi or a Kafka, these are components that allow us to have streaming data that allows us real-time access. And then capturing attribute information. And in this case, we do this across 60, 70, 80 different attributes. In our case, for every registered user of the network, we've captured somewhere about maybe 80 to 90 attributes of behavior, online behavior for individuals, and stored that as a pattern, which is essentially we call a risk profile against every user. And then we can do different things in different situations using that data and matching the real-time data against the pattern to determine what the deviation is. So the algorithm gets applied against the data, and in this case matches the real-time data to the pattern, creates a deviation score, and that deviation score translates into essentially what is a confidence level that determines how to treat that particular situation, all driven on the behavioral attributes. So this is like foundational to how we think about identity access management. So the conventional notion of, if I have a privileged user that's requesting privilege, I'm going to send a ticket or a alert to the security operations team, and they're going to respond and react to that. Now that what I just described, that privileged access management workflow, is very traditional, and every single auditor in cybersecurity would say, yeah, it's good practice to do. And the reality is when you send an alert to the SOC, especially an alert where somebody has privileged access, say domain administration privilege for a period of time, the SOC is so overwhelmed with so much other information that they're trying to prioritize, they're going to totally ignore that. And that's the best SOC in the world is going to ignore it, because it's just, there's no context for it. It's random. It makes the auditors happy. It looks like there's follow through, but frankly, it's a waste of time. And that's the conventional approach. The unconventional approach, which is applying data science, is to say, well, for the period of time when the privileged user has privilege, why don't we make sure that it's them? Why don't we make sure that their pattern of use of technology matches their norm, their established pattern? And if it does within a threshold measured by the deviation score, then we'll allow it. And if it goes beyond the deviation score, we'll automatically revoke privilege with no human intervention in real time. So that's an example of kind of the principle. So we can apply this to privilege access management, was the example that I just gave you. we can apply it to what we call next generation authentication. And I'll talk a little bit more specific about this and give you some examples of this. And then the last is dynamic provisioning. What does that do? Dynamic provisioning allows us to provision entitlements based on behavioral attributes versus roles. And so that gives us an ability, instead of having to approve entitlements, about 70–80% of all entitlements, we can automatically orchestrate and automate the approval process without any human intervention. So it's basically saving a bunch of time and effort, but also making it much smoother and easier for people to get entitlements. We'll create friction for the high risk entitlements, but for most entitlements, it's an automatic process. And it's all built on this UBA platform, user behavioral analytics, that where we're capturing all of the attribute information that I mentioned earlier for every single registered user on our network. And that gives us options and choices on how to apply it. So this is how model-driven security kind of works across an enterprise perspective. I talked about the privilege access management example of a privileged user. So I'm going to skip through that and go right to another really thorny problem that every enterprise has today. Passwords have been used for enterprise-wide authentication for over 60 years. And frankly, they've done a good job. They've been useful. They've been effective. They've been appropriate. And it's only in the last 5 years that it's not so much that passwords are growing in obsolescence, but what's happening is passwords and people, and the combination there is growing in obsolescence as an effective enterprise control. Now, why is that? Well, it's actually very simple and straightforward. Think of yourself and ask yourself, how many web digital assets and mobile digital assets do you have to get access to, or do you choose to get access to, over a period of time? And typically for most digital consumers, the numbers they're in the 3 digits. They're over 100. So there's over 100 different times that you've registered for access to something specifically. And you're required to use your user ID and password as credentials to gain continuous access to these digital capabilities. Now, I don't know about you, but I don't think any of us can remember 100+ passwords or user ID and password combinations. And so we have to invent different ways of coming up with complex passwords on the one hand, but having some level of convenience to be able to remember them on the other. And the reality is we don't do very well at this. And this is across, all use of passwords. Most of us use the same passwords across multiple sites simply because we can't remember them. Now, criminals figured this out again about 4 or 5 years ago. And so what they do is they harvest credentials, user ID and passwords. It's really easy to do credential stuffing if you have existing credentials. You can try them out on different websites until you get a hit. And it turns out about 2% of the time you're going to get a hit. And what does a hit mean? It means that through credential stuffing, you're going to own an account, an online account. And that gives you access to all the information in that account. And you can decide what to do. You can sell that access in terms of monetizing it, or you can sell the content, or you can just keep it, and sell the access to it. So the point is that it's pretty easy to monetize the account when you have the legitimate credentials that you can use and exchange. And that's what cyber criminals are doing today. And they're doing more of it and continuing to do more of it because there's no barriers to entry here. So what's the answer? And the answer is we have to think differently about authentication. Now, that's easier said than done. And here's what I mean. When I learned IT, and by the way, I'll use Nasser as an example. Nasser and I, when we learned IT, whenever that was, but rest assured, that was a long time ago. But whenever it was, we learned that authentication was an event. It had a beginning and an end. The beginning was the initiation. The end was either getting access or not getting access. So it was a binary outcome of an event. And over the years, what's happened is we've tried to inject more binary controls into that event. And that creates friction for the digital consumer, more things to remember. What I'm asking you to do is change the way you think about authentication and delete everything you've heard about authentication and everything Nasser and I learned about authentication as being an event. Because the more you stick binary controls within an event, the more friction you create for the end user. Now, you do create friction for the threat actor, but you're creating friction to the end user, and that's the cost of security and the online world. And as long as you think about authentication as an event with a binary outcome, beginning and an end, you'll always add friction to the equation. But if you start thinking about authentication as more of a continuous process, it's a game changer, because it allows an enterprise to create a capability without friction, so it improves the digital experience at a lower cost with better security. And it's something that we call behavioral-based continuous authentication. And it's all based on the same principle that I shared with you earlier of pattern matching to come up with a deviation score. It's just that we're using a lot of attribute information, and it changes the security architecture. So having that streaming capability that I talked about to get real-time data, absolutely essential to make this work, this aspect of continuous behavioral-based authentication. And that requires you to have a data lake where you can stream that data into and apply models against it. And of course, the decisioning engine, or risk engine, if you will, is where you're doing that pattern matching and coming up with the deviation score. There's some identity proofing that's necessary. And you want to link this, if you're doing it for consumers, to open standards like the FIDO Alliance has a standard called FIDO. And FIDO allows biometric information on any consumer mobile device chosen by the consumer to be fed into the risk engine as an attribute by following the standard. There's a little bit of PKI validation that goes with FIDO2 as well. And so essentially that becomes an input into your risk engine. And then you can connect that to any identity proofing capability in the registration process, because you don't have behavioral attribute information when people register for the accounts. And that's essentially the architecture across an enterprise that can be used both internally for employees and can be used externally for customers at the same time. So the benefits, as I said, is it's a much better digital experience, because you don't have to remember your password. You don't have an out of band verification where you're taking a one-time password and entering it into your mobile device in order to get web access, as an example. So there's no friction like that. There's far better security, because basically if you use multiple attributes, threat actors don't have the time or patience to try to crack this, because they'll just move on to another enterprise and use credentials that they've harvested. So there's not a whole lot of, if a criminal really wanted to disrupt this, they probably try to figure out a way to poison the data. But if you're using, say, 50 to 60 attributes, even that's really hard to do for the criminals. And criminals don't do things that are really hard, especially if they're in it for profit. They do things that are easy. So it turns out that in an enterprise with this model, you don't need password reset as a function. And it actually costs a lot of money to reset passwords, even if you do it in an automated way. There's a verification process. A lot of people use call centers. And so those are expensive ways. All those things go by the boards. And so you save money. And obviously it's a better security experience, fewer account takeovers, and better compliance as well. So I'm giving you kind of the data analytics and data management front end that's pretty conventional as we apply data science to cybersecurity. And then I've given you a couple of examples in a couple of different areas of model-driven security, which is really real-time using data models in real time, driving frontline security controls, which is kind of exciting and really opens up a whole new frontier for cybersecurity and for identity access management. So now's a good opportunity, because I've done a lot of talking, and this is your opportunity to ask questions. So feel free to offer some questions. There is, I think, a Q&A.
That's right. That's right, Jim. I can read out some. I see some questions here.
Sure.
So one question from Robert says, with your experience thus far, what activities across people, process, and technology do you plan to maintain, and what activities do you plan to retire? And what new activities do you plan to introduce? In the sense, what's working, what's not working? And this is in the context of your data science and data analytics activities.
Yeah, so Robert, it's actually a great question. And I've spent a lot of time with the identity access management operations team and the leaders of that team, explaining to them that their job's changing. And, you know, when you explain to people that their job's changing, that can be unsettling. So I have to be somewhat sensitive to that when we have the conversation, but the facts are that the job is changing. And in fact, the job of cybersecurity professionals is changing. And I'll give you a couple of examples of that. So in the traditional model, designing cybersecurity controls, you do the best you can with the information available at a point in time. And at the end of the day, you say, you know what, I'm going to notify the SOC, the security operations team, of an alert, and they'll figure out what to do with that. And that's been kind of the traditional approach to cybersecurity. And it's pretty generic, but it's, you know, relatively true. And in this case, what we're doing in control design is we're actually creating a model to apply against real-time data to trigger specific automation and a treatment strategy as an outcome as a result of the automation. And so the cybersecurity professional that's doing control design is basically doing data analytics. They're basically looking at the model, how it performs, looking at the transaction data in terms of the outcome, matching that back to the threshold, adjusting the threshold when necessary. So what would be an example of adjusting the threshold? Well, if I'm using 50 attributes to do authentication, and the entire employee population is now working at home, and GPS or location is one of the attributes, then maybe I want to weight that attribute much lower in the decisioning risk engine because it's changing, right? Their location changed. And as we come back to work post-pandemic, it'll change also. So I can actually weight that attribute or discard it if I wish by making adjustments to the model, and then also adjusting the threshold, which is that deviation score, in where the trigger is for the automated process. And that's a continuous process. So in the former traditional model, you implement the control, you run it, you're done. Cybersecurity professional moves on to the next thing. In this model, the cybersecurity professional is essentially a data analyst that's constantly evaluating the effectiveness of the model and the attributes being fed into it, and making constant adjustments with data science professionals helping that process. If you look at it from an identity access management perspective, from an operations perspective, if I'm approving a entitlement by saying, yeah, this is reasonable. This person with this role asking for this entitlement looks reasonable. And I'm going to say yes. And then whoever owns the resource is going to, double validate that. And there's a workflow to get the approval through email as an example. Then, that's the traditional model. In this model, once again, I'm the operations person. I'm becoming a data analyst, and I'm looking at transaction volume and potential adjustments to optimize that flow. So in both cases, my job has changed. The cybersecurity role is changing, and the operations team member is changing. And those are examples of activities that you discard, the older models, and the newer model-driven security are what you basically analyze and continue to adjust. Hopefully, Robert, that answers your question.
So thanks, Jim. And actually, this is a great segue into the next question. So Maria asked, can you tell us about the different skill sets of the people involved in building the system? Besides security specialists and data specialists, are there other skills that were needed, or are there specific skill sets within these fields that were instrumental?
Yeah, was that Maria who asked?
Maria.
Yeah, Maria, great question. Boy, you kind of hit the nail on the head with that. And Nasser and I've been working on this opportunity, I guess I'll call it, for a couple of years now, and it's going to manifest itself in terms of a curriculum. Think of the intersection between data science and cybersecurity. And so we have cybersecurity professionals that have to understand the fundamental construct within data science and how it applies to cybersecurity. And we have data scientists that have to understand the context for cybersecurity to again, effectively design controls. And so both professionals with, deep-seated, well-established professional certifications and skills and competencies now have to converge and deal with that intersection. And cybersecurity professionals have to understand control design is fundamentally different. And frankly, managing controls is fundamentally different. And data scientists have to build the models, and that means maintain the models, that means understand the models, because as any AI capability, we have to use our values and how we design the models, and the models have to continually learn, adapt, and improve, and we have to nurture that process. And eventually, someday, we're going to be sharing models from one enterprise to another and using them specifically applied to cybersecurity controls. And so the convergence or intersection of data science and cybersecurity is changing all of our roles and responsibilities to some degree. So whether I'm a data scientist or whether I'm a cybersecurity professional, our roles, our activities, our skills, our competencies, our ability to influence control design, it's evolving and changing pretty rapidly as a result of this intersection. And so what Nasser and I are committed to doing is creating the educational vehicles to allow both sets of professionals, data scientists and cybersecurity professionals, to be able to operate and to be able to do control design effectively in this new environment. So yeah, a lot is changing. Of course, you might say, well, how fast is this changing? And I will tell you that we had at Aetna about 300 machine learning algorithms driving frontline security controls, about 8 platforms in production when I left, and that was about 2 years ago. And MassMutual, we have about 90, I think, today, maybe 80, I think 80 in production. So I expect that we'll have, close to 500 at MassMutual in the next couple of years. And so each one of those models will be there'll be a caretaker, for it, and caretaker for many models. That will be a data science professional, and potentially a cybersecurity professional that's constantly looking at adjustments to those models. And so that opens up a whole new set and range of both skills and opportunities for those professionals that want to make an investment in this intersection.
Thanks. So there are a couple of questions on false positives or false negatives, right? So in your continuous authentication, the questions generally deal with how do you deal with them? What's the cost investment to, and is that a pain point? And how do you deal with it? Essentially, yeah.
Yeah. So I'll tell you this, and I'll use the experience at Aetna. So I got exposed to models way back a couple of decades ago. And of course, we called them econometrician models back then. And most, if not all of them, decayed over time. So there was a lot of maintenance that we did. But anyway, that was my first introduction. And what I've learned, and by the way, I had expectations going into this in cybersecurity that models would have to be tested, extensively for, 6 to 12 months before we'd ever put it into production. And we'd be very careful about that, knowing that those models might change and evolve based on the data, the amount of data, the volume of data, the access to data, et cetera. And what turned out is that if you've got some decent data science talent developing the models for you, the models actually operate a lot more cleanly than what I expected. I had a situation where my team was coming to me and saying, we've been testing these models for 6 weeks. We want to put them in production. I said, no, we got to do it for 6 months. And they said, well, they're performing really well, and there's very low, no false positive rate. We'll keep doing it for another month or so if you want, but we're not sure it's necessary. And I finally realized that the quality of the data science creating the models actually determined how effective those models were and the false positives on the outcome. And it was a lot less than what I expected and experienced in my previous life. And so, yeah, I'll take Aetna has about 10 million consumers using this continuous behavioral-based authentication architecture that we talked about. They have no false positives. And I know that's hard to believe, but they have no false positives. They do have false negatives, but they have 0.02% false negatives. Now, what's a false negative? False negative is when you use step-up authentication because of a behavior change and it wasn't necessary. It was the actual user, but they lost their device, or they broke their right arm, so they're typing with their left hand and instead of their right hand, and that caused different. They hold the device differently. The accelerometer readings are different. It doesn't match the pattern. It's a deviation that triggered a step-up authentication action. And so those are false negatives. So even the false negatives are really minuscule in terms of the big scheme of things. So I don't want to suggest that this is seamless integration that's easy to do, because you have to tell consumers, assuming you tell consumers that you're not using a password. And some consumers are uncomfortable. That makes them uncomfortable. And other consumers, they're like, hey, this is great. About 70%, I guess, from actual experience, just welcomed no password, option and said, yeah, this is excellent, much more convenient. There's about 10% of users that said, give me back the password, because at least I saw the security then. So at least I knew it was there. And now I can't see it. I just, get access automatically. I feel uncomfortable. Give me back the password. And then there's a group that basically says, what are you doing with the behavioral information? And the reality is we just keep the algorithms. We don't keep any of the attribute information, and we don't use the attribute information for anything other than authentication. But there's concerns about that, and legitimate concerns about that in the marketplace. So that's essentially how it breaks out.
Okay. Another question, perhaps the last one, because we're running out of time. So from Collins, saying biometrics would kind of increase the overall upfront cost, right, as compared to password resets. And would the cost of a regular password security eventually overcome the cost of a biometric implementation?
Yeah, Colin, so think about biometric implementation on the device, and specifically the mobile device. And if I'm an enterprise, I'm not doing any biometric implementation. You are. You're choosing your mobile device. If it's an iPhone, you're choosing Touch ID or Face ID. And you can choose to have a combination of both. As the enterprise, all I'm doing is I'm taking whatever choice you make for whatever biometric you choose on the device. That biometric is following the FIDO standard, giving me verification that you use Touch ID or Face ID or both, your choice, and giving me a PKI validation that that's your device that signaled it. Now, I can choose to authenticate based on that alone, if I wish, as an enterprise. I can also choose to add attribute information based on what's available through the electronic interaction to match, your browser fingerprint or to match the way you hold your device, right? So I can choose to do other attributes in a continuous fashion behind the scenes, and that protects the consumer and allows the enterprise to decide on that or not. But I don't have to implement biometrics. I don't have to do anything. I just have to follow the FIDO standard and accepting that as attribute information. The worst biometric implementation is when the enterprise actually has to do something and store the biometric. That's badness. That's not good for the consumer. It's not good for the enterprise because that biometric can then be hacked. So there's really no upfront costs using a biometric if you follow open standard. If not, then you do have to build it, but it's not something I'd recommend. Hopefully that answers your question, Colin.
Okay, thank you, Jim. I'm sorry I couldn't get to some of the other questions, but feel free to email them to me. And Steph, do you have any
I do.
announcements? Yeah.
Yeah. First of all, thank you so much, Jim, for being here, and a big thanks to the MassMutual team as well. They will be at the industry fair tomorrow, so you should check out their booth. They will have representatives there, I think, from 9:30 to 4. So really great coverage during the day, Eastern Standard Time tomorrow. Be sure to visit them. And a quick note is that up next, starting in a few minutes at noon, is the NYU Center for Cybersecurity Roundtable. So happy that you could join us. Again, Jim, thank you so much. Really appreciate it.
My pleasure, Steph.
Thank you.
Great.
Thank you, Jim.
Everyone take care.
Thanks, Nasser.